is our last section for the first chapter, and we're on 1.8. We're going to start a little bit of perimeter, circumference, and area. So perimeter is the distance around a rigid figure. So if I were to walk around this and add up all these sides, maybe that's 5 and 6 and 5 and 4 and 6 again. When I walk around it, I will be finding the perimeter. Kind of like if the police set up a perimeter at a concert or the perimeter of your yard. It's walking around the outside. So basically, all you have to do is just add up all of the side lengths if you have them, right? So on this one, my perimeter would be 11 plus the 8 plus the 13. That's it, really. And so we'd have 19 plus 13 would be 32. Notice the label. It's just in centimeters because we're just walking. So we should always have our perimeters labeled in feet, centimeters, inches, whatever the units are in the problem that we're presented with. So circumference is also a distance around, but it's specific to a circle. So the circumference is, if I were to cut this right here and lay just the blue line flat, how long is it, right? And the circumference is dependent upon the radius. But the diameter is twice the radius. So you might be given either one. So depending on what you're given, our circumference is 2 times pi. And if you were in class, I would have discussed a little bit about what pi actually is, but I like to keep these videos as concise as possible. So we can either do 2 pi r if we're given the radius. Notice, suppose that radius was like, say, 6, right? Just that green piece. I would put a 6 right here, and you'll notice I get 12 when I just leave the pi out of it. Well, if I was given the diameter being 12, I could just do pi times 12. So it doesn't really matter which one you use. I tend to gravitate towards this one. I just always have. So I just do. All right, so in the area is the amount of surface that gets covered. So this looks like it's about 3 centimeters. This looks like it's about 2 centimeters. So I would be measuring this in what I would call square centimeters. Well, if I chop this into 3 pieces and this into 2, I'd have what I'd call 6 perfect centimeters squared. And that's why we square when we do area. So our formula for the area of a rectangle is length times width or base times height, depending on who your teacher is. I'm fine with either one. I'm going to use base times height. So I do 3 times 2, or basically 3 centimeters times 2 centimeters. Will give me 6 square centimeters. So you might want to circle that label because they're important. If you were to go to Home Depot, there's a big difference whether you order 6 feet of something and 6 square feet of something. So this is about 1 foot long. My actual iPad is a square foot. Whoops, sorry, I hit my mute button there. So let's get that off of there. So what if we have a square? Well, is this a square? You don't know until there's a couple things I should put on here. All the sides have to be marked the same. Remember, we do side lengths being the same with the dashes, right? We also need to have little right angle boxes in there, or we need to be told that it's a square. So now I'm 100% convinced I have a square. And for a square, those side lengths are the same. So whatever this is, so is this. So I'm still doing base times height, but sometimes a square gets its own formula. And we say, well, you just can take a side and square it. Because when I do 5 times 5, I'll get 5. I've got my 5s kind of look like my S's there. I'll have 25. Well, what are my units? It depends on the problem. So if I say that this represented a 5-inch square, then I label it 25 square inches, and I'm done. All right, so we'll have area of rectangles, base times height. Area of the square is the same thing, but they're the same. So we can really just square it. So if you're told that this figure's a square and that its side length is 6, you can just say 6 squared. But if you want to do base times height, they are equivalent, right? So for the circumference, for the area of a circle, again, it's dependent upon that pi and specifically the radius. So we do pi times the radius squared. So if you have the diameter given to you, you will need to cut it in half to get that radius so that you can plug it in and square it. All right, so let's go to the next page. We'll talk more about how you would write your final answers. So a little practice here. I have a 5 by 7 foot rug. Well, here's my 5, here's my 7. Notice that my units are in feet. And it leaves a 2 foot of bedroom floor exposed on all sides, which means I've got 2 feet going this way and 2 feet going that way on all sides. So 2 feet, 2 feet, right? So it says, what is the perimeter of the floor? Well, for me to get the perimeter, I need to get the side lengths, right? So this side right here would be the 5, and then I'd have 2 feet left on the top and 2 on the bottom. When I add those, I get a 9, which means I also have a 9 over here. So how about the other side length? Well, it's 2 feet that gets left. You've got it perfectly placed there so that you've left 2 feet. So 2 on the left and 2 on the right, but 7 along the bottom. So I just add those up. Basically, I take the 7 and add the 4 feet that I have gapped out. So an 11 and 11. So what is my perimeter? I walk around. I don't do 11 times 9. That would give me the area of my floor. I would do walking around 9 plus 11 plus another 9 plus another 11. Or if I wanted to, I could say, well, I have 2 9s and I have 2 11s. Either way, you're going to get the same answer. So this one would be 40. 20 plus 20 as I go around. This is 40. So you can kind of decide if you want to double those instead of adding up 4 of them. What would my label be? This was perimeter. So this isn't square feet. This is distance around measured in feet. What's the area of the floor? Base times height measured in square feet. So when this says find the circumference, I'm going to write that formula down. 2 times pi times the radius. We have that on the previous page. This says find the area. I'll write that formula down. Pi times the radius squared. Was I given the radius? Yes. Okay, so I do 2 times pi times the radius. When it says in terms of pi, now if you were asked to round to the nearest tenth, you would just go to your calculator, go 2 times, and then press the pi button. Okay, so when it says in terms of pi, there's my grand dog was barking, so if there's a little gap there, I had to pause the video. It means do not touch that button on your calculator, leave it in your answer, and then multiply the 2 and the 4 together, and we'd say 8 pi. Again, if you were asked to round it than that, you would just go 2 times, hit your pi button, times 4, and enter it. But in terms of pi means pi is in our answer. Make sure you write it down. Sometimes kids will just put 8. I'm like, no, pi is a number, right? You've been probably conditioned to say it's 3.14, so this is about 24. Don't put a 8, just the 8 down. It needs the pi. And then how about my label? Well, remember, circumference is distance around measured in centimeters. So 8 pi centimeters. In terms of pi, write the area. Well, I have pi times radius, in goes the 4, squared. It does say in terms of pi, so the pi goes directly in my answer, and then I just do 4 times 4, which is 16. Now, some kids will write pi 16, and to me that's kind of weird. Like, I guess like if you were in algebra and you were supposed to do 3x plus 1, writing x3 plus 1 just looks weird, and so that's kind of what this does too. You lead with your whole number there. So we'd say 16 pi. This is area, so we would say centimeters squared. So a big difference between circumference and area, both numerically, 8 pi versus 16 pi, and then with our labels as well. So just be careful of the details. What am I finding with this triangle? I'm supposed to find the perimeter, so I need to find and add up the lengths of the 3 sides. I have length 1 down here, I have length 2 over here on the right, and then I have length 3 over here, connecting G to E. So I need to add them up. Length 1 and length 2 and length 3. Now 2 of those are super easy to find, especially since it's graphed here. Because remember, if I'm just on a vertical or horizontal, if I'm not moving up or down, I can just count like it's a street. How many blocks is this? Remember, we count the spaces, not the tick marks. So I have 1 space, 2 space, 3 space, 4 space, 5 space, 6 spaces. Or how far apart are the -3 and the 3, because I'm only moving horizontally, but we have 6. Same with my length 2 here. That's nice and easy because I'm only going up. I went from -2 all the way up to 6. That's 8. Or you could count the spaces. 1, 2, 3, 4, 5, 6, 7, 8. Fine, however you get it. Length 3 is the issue, right? Because it's on the diagonal, which means you need to use your distance formula. But remember that shortcut we talked about. When we do the distance formula, we do the square root of. Now, you can do it with the whole formula if you want, but we really just need how far apart are the x's. We already determined those were 6 apart. How far apart are the y's? Don't forget to square it, right? And we already determined those are 8 apart. Now, again, I'm going to repeat. If you actually use the formula and you don't just ask yourself, well, how far apart are these? 6. Square it. How far apart are these? 8. Square it. Then you could, the formula actually says, so I'm going to go under here just in case you like the formula. You do y2 or x2, -3, minus x1, 3. Circle them here in black, and you square it. But -3 down 3 is -6. And when I square it and do -6 times -6, I get 36. So it doesn't particularly matter. I'm just going to ... that. I like just to say how far apart are they, so I'm always dealing with those nice positive numbers and squaring them. Makes it nice. All right, so I have a 6 because I just had to walk to the right. I have an 8 because I just had to walk up. But for the diagonal, I needed my distance formula. 36 plus 64 is 100. And when I take its square root, I get 10. So this is really 6 plus 8 plus 10 for a nice 24. And that would just be units, where 1 unit represents the length of one of these boxes. So what I'm saying is all the way around the figure would add up to 24 units. All right, so our last thing is our last page over here. It says, find the area of a rectangle that is 3 feet by 11 feet. Oh, 11 inches. Good thing I highlighted that. I would have missed it, so be careful. This is 3 feet. This is 11 inches. And don't multiply them and get a 33 because you have to have the same units. So I always think it's easiest to take the bigger unit. Feet are bigger than inches or longer, have a greater magnitude than an inch. And I'm going to convert it into inches. So my 3 feet, how many inches is it? Well, you should know, but we'll put it on here just in case. That there's 12 inches in a foot. You should know that there's 3 feet in a yard. And 100 centimeters in a meter. And if anything else pops up that we need, we can just add it later. But that should get us through what we need for now. So again, I know I need to do base times height. The problem is, because this is a rectangle, the problem is I have to get the same unit. So my 3 feet is actually going to be 3 times 12, or 36 inches. So what I need to multiply is my 11 on the base times my 36. And I don't know what that is, and I don't have a calculator out. So you guys are just going to have to do that with a label of inches squared. So watch those units when you're doing your homework today. You're going to be on a worksheet, not Delta Math, and there's going to be a couple where you need to take and convert. So, and again, what did I mean by the larger one? Well, had that been, let's say, 2 meters by 14 centimeters, right? I would take my meters and convert it to centimeters, and there's 100 centimeters in a meter. And so I would just do that. And then do base times height. So watch the units is the moral of that story. A composite shape is made up of ones we know that are kind of put together. So like, I don't know how to find the area of this thing. It's kind of funky, but I do know how to find the areas of rectangles and squares. So a couple things to remember is that these dashes are telling you these are all the same. So every one of these lengths is 3. If you want to go put it on there, go ahead. Right? Also down here, because of the same number of dashes, we have a 9. So I'm supposed to find the area of the shape, which means I'm going to split it. Like, in how you do that doesn't really matter. I think I'm just going to make 1, 2, 3 different rectangles that I'm going to add up. This one over here on the far left is obviously 9 by 3. So when I do 9 times 3, I get 27 square centimeters in there. Now, how about this next one? It's still 3. But what's this length? And I challenge you to pause the video and kind of try to figure that out on your own. But in blue here, if this is 9 all the way, and this is 3 right here, then when I subtract off that 3, I'd have the length of this piece right here. So that's going to be 6. And I'm going to have a 6 by 3 right here in blue. This one's 6 by 3, which is 18. So right now I'm going to do the 27 from the one on the left, the 18 square centimeters from the one in the middle, and then my bottom one's nice and easy because it's just 3 by 3 because of those dashes that were on there. And I'd add those up. So I'd have 45, when I add these up, plus a 9, so 54. And how would I label it? And I would ask that in class, and hopefully they all go, centimeters squared. And I say, yes. So I challenge you on this last one for you to split it up and find the area, and then come back to the video. Well, there's lots of ways to split this up. I mean, I could go like this and like this. Maybe I want to go like this. Maybe I'm kind of a different problem solver than all the rest of the people in the room, and I'm going to do the whole thing. Because that's 7 by 4. That's nice, right? And then just subtract off this little piece that's cut out. I think I'll do it that way because I like it. Regardless, you'll get the same answer. So I'm going to take the 28 as if I just did base times height, and I got this whole thing right here. Then what I'm going to do is subtract out the area of this piece. I'm going to do a little subtraction. So I need to find its dimensions. It's got a height of 2. Right? And I do base times height, but this one I don't know. Well, again, if it's 7 all the way across, and I take off the 2 from here to here, as indicated by that 2 on the bottom, and the 2 from here to here, I'll be left with that one, which would be 3. So again, I take the 7 minus the 2 minus the 2. So I have my 28, and I'll subtract off 3 times 2, this little 6 square unit piece, and I get 22. I'll do it one other way too, just because most people wouldn't think to do it that way, but I'm not like most. So maybe you went like that. Well, this piece is obviously 4 times 2. Same over here. How about, again, so I'm going to have the 8 plus the 8, and now I've got this guy right here in blue that I need. Well, I need its dimensions. It's not 7 by 2, right? Because that 7's all the way across, but we already said if we take off this 2 and this 2, we'd be at 3. So this piece right here, we know to be 3. This right here would be 2, because I've got 4 the whole way, and then I've got this 2 right here. So that's just going to be 6, because it's a 3 by 2. When I add it up, I get 16 plus 6, which is also 22. And again, there's no label, so you wouldn't be docked if you didn't label it. That's it. It's the end of the chapter, and our homework is a worksheet. It is linked on today's slide. So if you are watching this and you are absent and you don't even have a printer, just do it on a separate sheet of paper. Don't opt to not do it. Just grab a blank sheet of paper. We're just fine with that.